We've just been talking about network hardware. Let's talk about network software now. This is called protocols. Now, protocols exist in layers, and let me show you what I mean by that. I've got over here something we call the Osi model, and you can see that these are the various layers. This is layer 7, the application layer, layer 6, presentation, layer 5, session, layer 4, transport, layer 3 is network, layer 2 is data link, and layer 1 is physical. So the applications, don't think of an application like Microsoft Word. Think of application in terms of the protocol or the software that allows Microsoft Word, say, to communicate with OneDrive. All right, so this is these application layer protocols are the ones that interface with actual applications. And then we change the data and we get the next computer's attention and so on. We do some addressing. This is where the IP address is added so that the router will know how, and by the way, routers exist here at layer 3, the network layer. And so this is how routers know how to communicate. This data link layer is how switches know how to communicate. Those are the local communication. And then the physical layers, the actual wires and so on. So data travels down this side. It goes across some medium, some routers and switches and wires and wireless and whatnot. And then it goes back up over here. And each time it goes from one to another, we're choosing different protocols that will be used, and different protocols have different purposes in them. Let's go back to our notes now and talk about some of these protocols. Up at the upper layers, layer 7, we have protocols like HTTP, FTP. Web traffic is best encoded in HTTP protocols. Files can be transferred using the FTP protocol. So you can see we have different uses for different ones of these protocols. TCP and UDP exist down here at layer 4, and TCP is something you need to know about. TCP is that it guarantees delivery. The thing about TCP is it makes a connection. It's called connection oriented. It makes a connection with the other side, and that connection is kept open until the communication completes. So TCP has this double checking system. Once a packet is sent, the receiving computer sends a response back saying that it got it correctly, and all of that is constantly going on so that you can make sure that that, say, web page gets there. UDP does not guarantee receipt. So this is like streaming data, for example. UDP is connectionless. There's no connection made. The data is just sent from one computer, and whether the other one receives it or not, who cares, right? So this is why it's really good. It's fast. This is why it's really good for streaming video, for example. IP occurs at layer 3. This is what occurs in the router. This is where the addressing takes place. These are very, very typical IP version 4 addresses, and in this case these are reserved address spaces that are used on a private network, such as the ones we saw up here when we were looking at hardware. So there is also something called the Tcp Ip Suite. Now this is similar to the Osi model that I just showed you, except that it is the suite of protocols that are overlaid on this model. In other words, the protocols that exist at each layer. And that is called the TCP IP Suite of protocols. And all of these, IP, UDP, TCP, HTTP, are part of that suite. And so, in other words, they are protocols that are designed to all work together and to operate at various layers of the OSI model.